Hi everyone, today's lesson is for geometry students. This is day 4 of chapter 3 from CPM book. However, we are covering a lot of similarity today, so let's get started. And first we're going to do a little bit of a warm-up. Examine the triangles below. Are these triangles similar? Why or why not? And so basically what we want to do is, if they are similar, then we can find the other parts that are unknown, if there's any parts that are unknown. But in the meantime, we do need to figure out and verify, are these similar? So what you need to do is make sure that the two triangles, for example, are set up the same way, like that. See how they're, like, I could turn that. I know it's easy to turn on my smart board here, but you might have to redraw it, is basically what I'm saying, to make sure that they line up so that the angles are the same. And that's the big deal. So if you look, this angle, which is 56.5 degrees, is the same thing as this angle in here. And if this angle here is 22.3, this would be 22.3. And if that was 100, that would be 100 as well. So they do line up. And so we'll go from there. The angles are congruent. If the angles are congruent, the side should be similar. So let's verify that and go 8 is to 12. So I'm just doing left side is to right side and I can't use this value is to 15 because I don't have that value. You have to have both values to check to see if it's similar. And then I'm going to go check that equal to 4, left side again, is to 6. So we're going to cross multiply. 8 times 6 is 48. Does that equal 12 times 4? 48, yes. And then you would say, therefore, those 3 dots mean therefore, you would say triangle. And if you start here at A, you're going to go triangle ATC is similar. That's how the little enye is similar to triangle GIP. And that's how you do that. So now that we have that done, let's just say, what's the scale factor? If I go left is to right, this scale factor is going to be 4 to 6, but 4 to 6 is actually reduces to 2 to 3. So 2 to 3 is actually my scale factor and also my ratio of perimeters. In order to find this length here, because they want to know what's the length of CT, then I just need to set up my proportion and use my scale factor so that I don't, again, have to reduce. I can go 4 is to 6, which is 2 is to 3. So 2 is to 3 as x is to 15. X is to 15. So we're going to cross multiply. We get 3x is equal to 15 times 2, which is 30. So x equals 10. Put that in solution sets because you are actually solving for x. And if it makes you, feel better to put it in a box, then you can box around the solution set, but that's the correct way to write it. And how do I know? It's angle similarity postulate, because if we have two angles that are similar to each other, then the triangles are similar. Call that the angle similarity postulate. And then we found x. What was x? X is 10, so we know that. Was there anything else? Nope. Okay, moving on. Our learning targets today, we're going to talk about ratio of perimeters, ratio of areas. We're going to talk about proportional sides. We're going to talk about scale factor, side angle side, and AA similarity, triangle similarity, and triangle inequality theorem, which there's a lot to do today. So this is just basically saying, hey, this kid here is looking at these two shapes, and he thinks that EFG is similar to HIJ. Now, I'm just going to say this one thing. Redraw the shapes, because I'm already looking at this right here, and that's the only thing I'm looking at. See this right here, EFG. I'm like actually going to redraw that shape like this. So I've got E and then F and then G. And I know that's 25, and I know that's 87. I don't know any sides. Then I'm going to draw this shape, which is HIJ. But I'm not going to look at this. When I redraw it, I'm looking down here. This is where I'm looking, because this has to be redrawn like the first one. So if I start E right here, if this is where I'm starting and I go up F, then this other triangle, I don't even care what that looks like there. This is going to go HI. Oops. That's going to go HI. So H, then I come down j. That's how my triangle is going to be. So now that I redrew it, I can put the stuff in it, right? I know h is going to be 68, so there's 68. I know that j is 87. That's going to be here. Now, I do see that my j's match up. And if they were similar, that would have to be 25, right? And, hold on, looking for my calculator. What's going to happen is if these are similar, then, of course, the sum's going to be 180. Let's check and see if that's right. So, right, 68, add 25 plus 87. Did I do that right? No. Let me do that again. 68 plus 25 plus 87. I get 180. So the sum of these angles is 180, which means that this lines up with this. This lines up with this. See how they're both the same? That means that's the angle-angle similarity postulate. It's like a inequality theorem that they have that basically says, it's sort of like a no-brainer too, because, I mean, if you have two sides that are congruent to two sides, then, I'm sorry, not sides. If you have two angles congruent to two angles, here and here, these are equal, those are equal. The third angle has to be equal. Okay, you just subtract from 180, you have to get the same angle if they're equal. All right, so yes, those are similar. This one is not asking me to compare anything. It's just saying find the following ratios in simplest form. That means that the measure of the smallest angle, which it looks like it's 26, but let's just check, okay? Because let's see, we're going to go 180 minus 91. Let's do that. 180 minus 91, and then minus 26 is 63. So we know that this is 63 degrees, okay? Now, they want you to make a ratio with the smallest angle, which is 26, to the largest angle, which is 91. So we're going to go 26 is to 91. And then I guess you can, let's see, divide, and I'm going to go to math. I get 2 over 7. So my ratio is 2 over 7 when I'm comparing the angles. That is not my scale factor. Do not think that that's a scale factor. To get a scale factor, you have to have two triangles, right? And you have to compare two different triangles. But we are only comparing the angles in one triangle, okay? Then I'm going to make another ratio for BC, there it is, 27, to the perimeter of ABC. Well, the perimeter is going to be 12, 27, and 24. Add those up, right? 12, 27, 24, 63. So 27 is to 63. Looks like I can divide by 9 in both. So 3 here and 7 here. So that's the ratio of BC to the perimeter. Again, not my scale factor. So just be very careful and be aware of that, okay? Ratio of perimeters does use scale factor. And we actually did this slide in some of the classes, but not all. So if I want to find the scale factor, okay? I'm going to compare two sides. As long as they're lined up, looks like this angle is to this angle, this angle is to this angle. By the way, that's angle-angle similarity. 2 is to 4, so we're going to go 2 is to 4. Now, that's going to reduce, right? Same thing. I could have said, no, I couldn't have because I didn't have all the other sides. 2 is to 4, so that's going to be 1 is to 2. So if we go small is to large, right? You would say, this is what you're saying. You're saying triangle ABC is similar to triangle, start A up, oh, I went A, B, C, didn't I? So then that would go D this way, E. So it would be similar. So let me redraw that. Triangle A, right B, C is similar to triangle D, right E, and then up F. So that's how you have to do that. You have to look at it and you have to say, okay, where are they going? My scale factor is 1/2. If I want to find letter A, I'm going to go 1 is to 2, which is that 2 is to 4, as A is to 10. So I'm going to cross multiply. I get 2A equals 10, A equals 5. And yes, it's a solution. Put that in there. So A is 5. So now I'm going to find F. Now, some of you are actually looking at this going, 14, it's 14, it's 14. Actually, yes, it is 14. Because look, 5 times 2 is 10. 2 times 2 is 4. So that would say 7 times 2. What happens with the scale factor, when you're going smallest to largest, you can multiply by the reciprocal of the scale factor to get the other value. Now, think about this. I'm trying to find what's called the ratio of perimeters. So let's add these up. 2 plus 5 is 7, plus another 7 is 14. So that's going to be 14, small triangle to large triangle. 4 plus 10 is 14, plus 14 is 28, and I get 1 over 2. So what this is telling me is this, that the ratio of perimeters is a half, which means that my ratio of perimeters is equal to my scale factor. Okay, cool. Next, ratio of areas. So what we're looking at here is, it says find the, okay, we're assuming that these are proportional, because why? Because they have 3 angles congruent. So that means that by angle similarity, these 2 triangles are not congruent. No. If you have congruent angles, they give you if you have congruent angles, then they give you similar sides, or proportional. The triangles are similar if you have 2 angles that are congruent. Okay? If your triangles are similar, then the sides are proportional. So here we go. 5 is to x, so I'm going left side is to right side, as 3 is to 6. So 3 is to 6, which is 1/2, which means that my scale factor is small to large, which is 1 over 2. Yeah, 3/6. So I'm going to lose the 3/6, because why multiply by a bigger number than you have to? And I'm going to go 1 over 2. Cross multiply, I get x equals 10, and we're done. So x is 10. So let's see. Let's clean this up a little bit. And we have x is 10 right there. All right, so now, I mean, you probably can figure out that a is going to be 4, right? Because if you multiply times 2 to get the other side, you're going to divide by 2 to get back. So we know a, okay, so now they want to know what's the ratio of areas. So we're going to go, we have to find the area of both triangles. So the area of the smaller triangle is, again, 1/2 base times height. So 1/2 base is 4, height is 3, and the 5 is just not a number. We can use that in perimeter, but we're not using it to find the area for sure. Okay, and so we are going to go, the area of the small triangle is 2 goes into 4 twice, 2 times 3 is 6. So the area of the smaller triangle is 6. Now, unit squared, by the way. If I want to find the area of the larger triangle, right, we're going to go 1/2 base again, 8 times height, 6. Again, 10 is not used. 2 divides into 8, 4 times 6 is 24. So now, if I am making a ratio of my areas, I get 6 to 24. Now, I'm going to reduce that to 1 to 4. And this is my ratio of my areas. This is my ratio of areas. Okay, is 1 to 4. Now, remember the ratio of perimeters. I could add those up if you want. 8 plus 4 is 12. Let's see, 10, 18, 24. Ratio of perimeters is 1/2. So what you're looking at is this, okay? I mean, when it's all said and done, you've got your scale factor, which is 1/2. You've got your ratio of perimeters, which is 1/2. You've got your ratio of areas, which is 1/4. And so what that means is we are going to take the scale factor, 1/2, or the ratio of perimeters and square that. And that's going to give me 1/4. That's how you find the ratio of areas, is you square the scale factor. That's it. So if my scale factor was, let's say, 4/5, and I wanted to know what the ratio of areas was, I would get 16 over 25. Okay? And that's how you do it. Okay, so which of the following statements are correctly written and which are not? Note that more than one statement may be correct. Okay, so let's look at this. Again, this is backward. Is it backwards? Yeah, it is. See how it goes long, short, long. So DOG. So this is saying DOG must be similar to, I have to redraw this. And I'm going to draw another one of these triangles. So it's got to go, okay, let me fix this. Okay, so you just got to be really careful with this. Okay, that's not going to work. I'm going to go, actually, that just gave me an idea. to bring it over here, but make it bigger, okay? So now if I go DOG, right? DOG. If these two triangles are similar, then it's going to go C up T and then A, or go CAT that way. But this is DOG, so it's like, yeah, it's very strange. So this would be, okay, what is this saying? DOG is similar, DOG is similar to CAT, no. Let's do it again. DOG, right, is similar to, so you're not looking at this. You're looking at this one because you had to redraw it. So it goes D up O, it goes C, T, A. So this is correct. Okay, now let's look it down here. Start on a different letter. It says O, start on O, so it's going to go OG, G right, OG, D is similar to A. No, because I got to start at the same letter. So that's wrong. Okay, D, now let's try a different one. Okay, new picture. Okay, so this is going to be DGO. So go D, that way G, up O is similar to C, that way A, T. Correct. Correct. These are both correct. Cool. All right, these two triangles are similar. Given the two similar triangles, they're telling you they're similar. Find the value of M. Okay, right off the bat, they're saying start with ABC. So they're starting with the smaller triangle, okay, and they're making it similar to the next triangle. I am not going to look at this at all right now. When I redraw this, I'm going to just redraw a bigger version of that, okay? That's it. And I'm going to label it. If it goes A, up B, right C, this will be X, up Y, right Z. That's how you do that, okay? So now let's erase this and put the values in that we know, okay? We know that XZ is 11. We know that XY is M. There you go. And that's all you know. Okay, so I mean, like, literally, I would just like cross this out because you don't want to be distracted by that. Okay, so now we're going to find the value of M. So M, 7 is to M. You're going to go left side is to right side. So you're going to go 7 is to M as 6. Nope, there's no value here. So we can't use 6. That's out. As 10 is to 11. You have to have the same comparing sides. We call those corresponding sides. 10 is to 11. Okay, we're going to cross multiply. 10 times M is equal to 7 times 11. I'm going to go M equals 7 times 11 divided by 10, which doesn't like reduce. So my answers are going to be 77 over 10, which is completely fine. Yes, you can call that 7.7. Usually I like to keep your answers in fractions, but it's completely fine. For this problem here, it's saying, are these two triangles similar? Okay, yes or no? And it says that this person dilated them. So would that be true? What is the relationship and all that? Now, assuming that, and I know we're assuming this, that this is parallel maybe. Let's not assume it's parallel because it actually doesn't even say that, right? But what I do know is that I've got this little triangle up here on top. And I also have this big triangle here that is underneath that little triangle on top. So I know this, I get that, okay, that you can't do this. I'm going to move this over here, but I'm going to split this up into two parts because what that's going to do is it's going to tell me, yeah, if they're similar, are they similar? Why are they similar? And the only way these two triangles would be similar is if this was parallel to that, which it doesn't say, which we would have to assume it is, and that it's dilated. And if a dilation occurs, is that it just makes it larger, given it's like a translation of a larger shape. So then that would be similar. So this is A, this is B prime. Oh, they don't give me very good letters here. B prime, and this is C prime. This is B, this is A, and this is C. So I know that this little side here is 4, and this little side is X. I know on the right side that this side is the whole length, right? You want the whole length of AC. So that's X plus 9. And then on the left, that's going to be 4 plus 6, which is 10. So now let's create a a proportion, we know the scale factor, right? The scale factor is going to be 4:10, which is 2:5. So that's my scale factor. It's my ratio of perimeter. And then I already know the ratio of my areas is going to be 2/5 squared, which is 4/25. All right, so then we're going to go 4:10. I'm not going to use 4:10. I'm going to use 2:5. So 2:5 as x is to x plus 9. I'm going to cross multiply. I get 5x equals 2 times x plus 9. I get 5x equals 2x plus 18. I'm going to subtract 2x. I get 3x equals 18. And then I'm going to divide by 3. I get x equals 6. That's a solution. Put it in a solution set. And so we found x. X is 6. And I think that's it. And if then it is dilated, then this angle here would be congruent to this angle here, because then those would be corresponding angles. Corresponding angles come from two parallel lines cut by a transversal, and this would be my transversal with my two parallel lines going like that. They didn't say it was parallel, but we know it's parallel because the shape was dilated. Okay, and this is the same problem. I just redrew it. Okay, and there you are, Annika. Annika is examining the triangles below. She suspects that they might be similar. So let's see if they're similar. Now remember, if these triangles are similar, they at least have to have one angle or two angles, right? So far, we've just been talking about the angle-angle similarity. I wonder if there's another way to do it. So let's see if we can make a proportion. 14 is to 44.8. Like that. 14 is to 44.8 as 20 is to 64. Okay, so if we cross multiply and they're equal, then they are similar. And then Annika's right. So we're going to go 14 times 64. Does that equal 20 times 44.8? So here we go. Let's see. 14 times 64. I get 896. And then we've got 44.8 times 20, 896. So what this means, therefore, the two triangles, and the way you say them is important. So however you say them, you have to be consistent. So if you go T first, if I say triangle, T first, and then I go right Q, and then U, that has to be similar to triangle I first, right K, and then F. Do you see that? That's important that you say it the right way. If two triangles are similar, okay, if the two triangles are similar, then we know that the sides are proportional, right? Now, what we just did was we found that the sides were proportional. So therefore, we went backwards. The two triangles are similar, okay? So again, if I would have said in the very beginning that these two shapes are similar, then you would have said the sides are proportional. Well, if I say that the sides are proportional, then you can say that the two triangles are similar. Now, the way we did that, though, the reason for that was this. Look, side, that's a side, and an angle and a side. We call that the side angle side similarity postulate also. So far, we've got angle, angle. Remember where we had two angles like this, where they were congruent? If the angles are congruent, the sides are proportional. Okay? But in this case, this is a new one. This is a new one. And this is saying side, angle, side. If you have sides proportional and there's an angle in between, then the two triangles are similar. Yes, definitely. Okay. There's something called the triangle. This is new. The triangle inequality theorem. This is the real name for that. The sum of the lengths of any two sides of a triangle have to be greater than the length of the third side. So, and that has to go all the way around. Okay, so what that means is I have to go z plus x, these two, have to be greater than y. Not equal to, greater than. Additionally, it has to go all the way around. So not only does this have to be true, but then x plus y also has to be greater than z. And these two, y plus z has to be greater than x. So for this to be true, it has to be true all the way around, not just two parts, okay? So what I have is two things here, two little like examples that I would like to share. And the first one says one of my sides is 4, the other side is 4, and this is 7. So if I did 4 plus 7, that's 11. 11 is greater than 4. 7 plus 4 is 11. That's greater than 4. And 4 plus 4 is 8, and that's greater than 7. It has to go all the way around. So therefore, this triangle exists, basically. That's what you're saying, okay? But this triangle has this long length of 7 and these two short sides that are like trying to meet, but they're not. So what they're saying is, look, if you went 7 plus 3, that's 10. That's greater than 3. And so like some people will only check two sides. You have to check all the way around. So 7 plus 3, that's 10. That's also greater than 3. But when I check this way and I go 3 plus 3, right? 3 plus 3 is 6. And 6 is not greater, how did I write that? It's not greater than 7. So if 6 is not greater than 7, that means that this triangle right here does not exist. Because in order for it to exist, you have to have two sides greater than the third side. You can't just say they're equal to or they're less to. It has to be greater than. So here's two sides of a triangle, right? We got a 5, we have a 15, and we have another side, I don't know. It says, what's the length of the third side? How do I know what it's going to be? Well, I know that, right? You're going to add, there's a little trick to that. You're going to add them and you're going to subtract them. So you're going to go like this. X has to be, like, right? It's going to look like this. So you're going to say 5 plus 15 is 20. Okay? So 20 has to be greater than whatever X is. 15 minus 5, right, is 10. So that means that X has to be greater than 10. So you're going to add them here, and then you're going to subtract them here. And that's like the little trick, okay? And by the way, both of these are just going to be less than, but not equal to. So let's do this one for 20 and 14. So again, we've got this triangle, right? We've got, this is, let's say 20, that's 14. And how do I find that other side? Let's call it, I don't know. On the right side, we're going to add 20 plus 14. So that's going to be 34. On the left side, I'm going to subtract 20 minus 14, and I'm going to get 6. So that means that it has to be greater than 6. So I mean, like, plug a value in. So 7. 20 plus 7, yes, bigger. 7 plus 14 is 21. 14 plus 20, so that works. Do you see how that is? Okay. Triangle inequality theorem. Now, is it possible for these triangles to exist? And this is what we were just doing. So for me, what I would suggest you do is you pause the recording, and then you come back and you say, okay, yes, no, and you compare your answers to what I have. Okay, so I'm going to pause the recording to do that. Cool. So for this problem here, it says, so for this problem here, what it says is that they're trying to find out that if you can actually have a triangle that with these lengths. So what we have is a triangle, and if you want to draw these, you can, and it's not required. You don't have to do that, but we have 9, 2, and 6. So remember, two sides have to be greater than the third side. So 9 plus 2, right? So you can write a little chart. 9 plus 2 is greater than 6, yes. 9 plus 6 is greater than 2, yes. 2 plus 6, which is 8, is that greater than 9? No. Therefore, this triangle does not exist. And like realistically, it kind of looks like this little 2 here, and then you've got this happening, and it's like these two pieces that are never going to touch. That's what's happening. For this triangle here, you've got 1, 1, and 4. We are right off the bat, even though two sides, 1 plus 4 is greater than 1, 1 plus 4 is greater than 1, we know that 1 plus 1 is not greater than 4. So therefore, this triangle also does not exist. Now for this triangle here, another triangle, this happens to be a right triangle, by the way, it's a 3, 4, 5, do you notice that? So for this triangle here with 3, 4, and 5, 3 plus 5 is 8, greater than 4. 5 plus 4 is 9, greater than 3. 3 plus 4 is 7, greater than 5. This would be a definite yes, this triangle does exist. For this one right here, again, you've got 10, 10, and 0.5. Obviously, I didn't draw this to scale. But 10 plus 0.5 is greater than 10. 10 plus 0.5 is greater than 10. 10 plus 10 is 20, greater than 0.5. So this also is a huge yes. Now this one is saying a different concept. Which segment is the longest in triangle ABC? Well, for this right here, we know that a 60, 60, 60 is an equilateral triangle. So if that's 61, we're going to take off 1, so we know that's 9, 59. The longest segment is always opposite the largest angle. And in this case, the largest angle is 61 degrees. So BC, segment BC, would be the longest. For this one, it's saying which segment is the longest in triangle BCD. So for this triangle, again, so we've got 61, we have a 59, and we have a 60. The longest side is always opposite the largest angle, which is 61. So this would be right here, the longest angle. So the longest angle, or the largest side, would be BD. So then lastly, you've got, well, which segment is the longest overall? Now, again, this is a kind of a tricky question because normally, right, the longest side is always opposite the biggest angle. But what we have is 61 being a very large angle. And what you're doing is you're looking at this and you're like, BC must be my longest side. However, 59 is not the largest angle in this triangle. Therefore, because this and this one, they don't match up. They're not both the largest angles in their triangles. It's negated. And you can't negate that. You can't get around that. It's done. They cross each other out. It's called a negation. And so therefore, 61, there, BD, must be the longest side now because the other two negated each other. They canceled each other out. Name the largest and the smallest angle of the triangle. Again, the largest angle is opposite the smallest side. Smallest side is opposite the largest angle. So we don't have any values here, so I'm just going to make a value. So I'm going to say on the side, let x equal 1. Okay? So x is 1. So that means this is 1. This is 1 times 2. And this is 2 times 1, which is 2. Add 15, which is 17. I mean, realistically, this isn't even a triangle, right? Because 2 plus 1 does not equal 7, is not greater than 17. But if they just want to know the largest and smallest angle, if this was somehow a triangle, the smallest angle would be J. The smallest angle would be J. And the largest angle would be opposite the largest side, which would be K. But realistically, look at the sides, okay? For this one, you got to be careful. Let x equal, we're not going to let x equal 1 because that'd be 1 minus 3 and I have a negative value. So I'm going to say let x equal 10. So here we go with 10 here. 10 plus 3 is 13. 10 minus 3 is 7. So this is a triangle, so we like that. So again, the biggest angle is opposite the biggest side. So H would be the largest angle. And then the smallest angle would be G. Because, again, it's opposite, G is opposite the smallest side. And that's how you do it. These two polygons are similar. Check. They're telling us they're similar. Write the similarity statement. So basically, whatever letter you start on, that's where you go. So I'm going to start with P. Actually, it doesn't even matter where I start, but I mean, you can start with the smallest, like the earliest letter in the alphabet or not. So I'm going to say P and then go right or left. I'm going to go right. P, S, R, Q is similar to the other shape. Is that the same? If it's similar, that's 100, that's 60, that's 65. Okay, and then if I started with P, then I need to start with L. So L, O, N, and then M. Check. Fill in the angles, missing angles. Well, I mean, we're only missing one, right? And what you need to know about this is that the sum of the angles in any quadrilateral add up to be 360. So I'm going to go 160 plus 65 is 225, and I'm going to subtract that from 360, and I get 135, which means that this missing angle here and here are 135. So you'd say like this, you'd write it like this. The measure of angle N is equal to 135, right? You'd say the measure of angle S, which is this one, is equal to 60, and so on. And you just 60 degrees, etc. Okay, so part of learning something new is also being able to know when it's not being done correctly. So what they want to know is what's wrong with the solutions for X. So if I'm looking here, right, you got to be careful because it does look like these two triangles have been twisted, doesn't it? And so if they weren't twisted, I would have this angle here, right here, lined up with this angle here, with this triangle, okay? And so that's what you have to understand. Like this would be here, and then this would be the top part. So that would be a right side 9, and this would be a right side 6. The X would be on the bottom. So if I were doing this problem, I would be saying 6 is to 9 as X is to 8, right? And notice that they didn't do that right. Okay, so it's got the wrong scale factor. Number one, the scale factor is 6 to 9, which reduces 6 to 9 by 3, right? So that's going to be 2 to 3. So the correct scale factor is 2 to 3, not 3 to 4. Okay, so you got to be careful and flip those triangles. For this one, though, this one's already set up. Obviously, it's set up on top of each other. So what I would do, honestly, is just redraw these again, and then you're just going to get used to that because that has to be done. So for the smaller triangle here, we've got this is 10 and this is 14 for the larger. See the 10 and the 14? For the smaller triangle, we have X on this side and we have X plus 6 on the right. So now all we have to do is solve for X by making a scale factor. So we're going to go by making a proportion. I know that my scale factor is 10 to 14. And because I've got base to base. And I know that these two triangles are similar because these angles are congruent by parallel lines, and these are corresponding angles. So we have the angle and the angle. And actually, the top angle is the same value, isn't it? So it's like the angle similarity postulate. Divide by 2, I get 5 over 7, so my scale factor is 5 over 7. So I'm going to go right side is to right side. I'm going to go X is to X plus 6 as 5 is to 7, which is 10 is to 14, but I reduce that to 5 is to 7. So now all I have to do is cross multiply, and I'm going to go 7 times X equals 5 times X plus 6. We're going to get 7X equals 5X plus 30. I'm going to subtract 5X. I get 2X equals 30, and X equals 15, and put that in solution sets because that's an answer solution. Again, same kind of problem. I'm going to split these up and let's see what happens. Okay, sort of not the best drawing, I get that. 9 here, 12 here, X here. That's for this little triangle. For the left side of the bigger triangle here, looks like that's 9 plus 3, which is 12. The base is 8. And the right side is going to be 12 plus y. So what we need to do is to find X and Y. So my scale factor is 9 to 12. You've got to find two sides that you have. And those are the only two sides you have. 9 is to 12. And I'm going to reduce that by 3 and get 3 is to 4. Okay. So we're going to go 3 is to 4 so that's the 9 is to 12, which is my 3 is to 4. As I'm going to go X is to 8. I'm going to do that first. Cross multiply, I get 4X equals 24. X equals 8. So we're done with X. To find Y, I'm going to go again, 3 is to 4. But now I'm going to go 12 is to 12 plus Y. So 12 is to 12 plus Y. And in doing this, I'm going to cross multiply 4 times 12, which is 48. Equals 3 times 12 add y. So we get 48. I think I need more space. And I know that gives you the answer there, but I'm actually doing that for you. So we realistically don't need, that's not even, oh yeah, it is. Obviously I need that because I divided wrong. If you look at this, see that 6x is 6. 24 divided by 4 is 6. Hello, I can do math. Okay, so then we've got equal to 3 times 12, which is 36. Boy, I'm on a roll right now. 3 times 12, which is 36, plus 3y. And so I'm going to subtract 48 minus 36, and then I'm going to get 12 equals 3y. So y is equal to 12 divided by 3, which is 4. Okay, and we're done. So just talking about the two similar triangles, what they are, what the postulates are. We've got the AA postulate, which is the angle postulate, which says two angles of one triangle are congruent to two angles of another triangle. And if your third angle is this angle here, must be congruent to this also, if you already have two angles that are congruent. And this is just the same value here. Remember, we did this in the other problem where where we flipped them. But if I have this angle congruent to this angle, that's one angle. I also have this angle congruent to this angle. Those are vertical angles. Now I've got two angles in one triangle congruent to the two angles of the other triangle. So therefore, yes, these two triangles are similar by the angle-angle similarity postulate. It's telling me that they're similar. Why? Angle congruent to angle, these are corresponding angles. Angle congruent to angle, corresponding angles. Angle congruent to angle. So there's at least two angles congruent or more, right? Because again, if I have two angles that are congruent in one triangle, they have to be congruent to the other. So these theorems for similar triangle, there's actually a new one called side, side, side. It just says that the sides are proportional, then the triangles are similar, and we already know that. If this side is proportional to this side, if this side is proportional to this side, and this side here proportional to this side here, then the triangles are similar. If an angle of one triangle, okay, so they're saying if an angle of one triangle is congruent to an angle of another triangle, they're both 50 degrees, let's say. And you've got these two sides here, this side here, proportional to this. Now, they are not congruent, but they are proportional. So I can say if this is 10 and this is 5, then if this is 20, right, then this would be 10. So if I'm dividing by 2 here, then I have to divide by 2 here. And you can set up a proportion and go 10 is to 5 as 20 is to, 10. And if you cross multiply 10 times 10, which is 100, equals 5 times 20, which is 100. So therefore, by side, angle, side, these two triangles are similar. Okay. These are the postulates and theorems that they use. And there's a inequality, the triangle inequality theorem as well, but these are postulates that are the sides and the angles. So we've got the side, angle, side. So again, you've got a side proportion, these two sides are proportional to two other sides, and then the angle in between them, we call that the side, angle, side. The side, side, side just means that, doesn't mean anything about them being congruent. It means that all sides are proportional. That's what that's saying. And then the angle-angle postulate, similarity postulate, is saying two angles of one triangle are congruent. Here we go. The angles are always congruent to two angles of another triangle. Then, therefore, the sides are in proportion. Can the two sides shown be proven similar? Well, we'd have to check, right? You're just going to go, that's 10. I know it's a little bit light. So let's see. 10 is to 16 as 20 is to 24. You just have to multiply. I know 10 times 24 is 240. 16 times 20 is, 16 times 2 is 32 with a 0. These are no. That's a no. you got to be careful, because had I not chosen 20 is to 24, which doesn't work, right? To the 10 is to 16. And had I chosen 10 is to 16 as 15 is to 32, right? Just watch. 10 times 32 is 320. 16 times 15 is 240. Oh, those don't work either. Never mind. This is a no. Because they're not proportional. Oh, those aren't similar. That's a no. I know it says yes. That's a no. These ones down here, though, if you're looking at these and you're like, and I can't see that. Let me put my glasses on. 70 here. Okay, so if that's 70 plus 60, right? You've got 130. So you've got these two angles here. These two angles add up to be 130, which means that the sum of the angles of a triangle is 180. 180 minus 130 is 50. This would have to be 50, right? So 70, and if that's 40, 70 and 40, so 70, right, plus 40 is 110 from 180 is 70. So if you look at these, I mean, do they even look like they're proportional? No. If two triangles are similar, then first of all, the sides are proportional. I don't have any sides. But second of all, the angles are congruent. In this case, the angles are not congruent. And if the angles are not congruent, then the sides are not proportional. And therefore, the two triangles are not similar. For this shape here, can these two triangles be proven similar? You would need to flip this, because yes, this is congruent to here. We know that. Vertical angles are always congruent. But you'd have to redraw this triangle. So like if I drew this right here, okay, and I'm going to move that up here. That right there, I know it's a little bit smaller, right? But that's what I'm looking at, is not that. I'm looking at this right here with this. So let me redraw that, right? So I've got RQ is at the bottom. Because I flipped this, this is U, this is T. And then S is up here. So it's like I took this point and I flipped it up here. I moved it to the top here. Okay, and then switched those two sides. So ST is 6, SU is 9, and UT we don't know. So let's see. Are they proportional? If they are proportional, if the sides are proportional, then the triangles are similar. So, and we're not going to look at this right here. Don't look at that, because we just redrew that up here. So here we go. RS is to US. So that's going to be 12 is to 9 as 8 is to 6. So as 8 is to 6. If these multiply across and they're congruent and you get the same values, 12 times 6, right? If 12 times 6 equals 8 times 9, well, 8 times 9 is 72. 12 times 6 is 72. These are equal, therefore proportional. If they're equal, the sides are proportional, therefore the triangles are similar. So we're going to write our similarity statement. So I'm going to start with S, and I'm going to go S, right, Q. So S, Q, and then R. And now for this one, I'm going to go S, right, T. So S, T, okay, sorry, ST, and then U. All right. For this problem here, they're saying all these different triangles are similar. For this, though, we did talk about this before with the means, just briefly. And we went basis to height as height is to base, like that. We said 16 is to 12 as 12 is to y. Now, I do know that you can do this another way by making the sides proportional to each other, but we also know how to find the mean, and so we're going to use that. So we're going to go 16 times y equals 12 times 12. If I divide both sides by 16, I'm going to get y equals, let's see, 16 is actually 4 times 4, right? 4 divides into 12 3 times. 4 divides into 12 3 times. 3 times 3 is 9, so y equals 9. So this is 9. Now, a couple of options that I have, okay? Option number 1, okay? If I want to I can use the Pythagorean theorem. And I can say, because base, right, a squared plus b squared equals c squared. Even though I know the letters are off, but it doesn't matter. Leg squared, so I could go 12 squared plus 9 squared is equal to x squared. Totally do that. That would be 144 plus 81. What is that? 5 to 225. So 225 is equal to x squared. And when I square root this, right, I'm going to get 15. So x is equal to 15. And so that's one way of doing that. There's other ways to do this. I've got all the different ways to put this here. Okay, but what they did was just a little bit differently because they didn't use the means, which is completely fine. But you end up getting the same value for x. If you notice, this is x is 15, that's right here. And then y is 9 here. But we just did that different ways, and that's completely fine if you want to do that. So basically our learning targets, we had a lot of stuff for this class. We had perimeters, we had ratio of areas, we had scale factors, we had the side angle side and the angle similarity postulates. We also introduced side triangle theorem, and we also had the inequality theorem, which said that two sides of a triangle have to be greater than the third side. So very good. Homework for today is going to be these two assignments here, so I would suggest you work on that, and good luck. Have a great night. Thanks for watching.